Hello my dear students of BSc 5th semester. So welcome to my physics classes by Sarbdeep Kaur Sidhu. So today we will discuss a topic that is a reciprocal lattice. Reciprocal lattice, it's also called Fourier space, K space, momentum space. Yeah, other names of this: Fourier space, K space and momentum space. So first question arises that why we need reciprocal lattice. So we have studied in the previous lectures about the direct lattice. Yeah. So why we need this? In X-ray diffraction methods, you have different crystal planes. Okay, that crystal planes diffract the X-ray in different direction. So there are a set of crystal planes which have different slopes and different interplanar spacing. So it is difficult to visualize all that slopes and interplanar distances. So to improve that discrepancy that is in the previous methods, we need reciprocal lattice. So reciprocal lattice, why we need this? To know, you have to study the different interplanar spacing and slopes of different crystal planes. Yeah. So first of all, how we construct a reciprocal lattice and what is a reciprocal lattice. So this is a definition of reciprocal lattice. So how we can define this reciprocal lattice? It is a set of, write down, it is a set of imaginary point. I will tell you each and everything. It is a set of imaginary points constructed in such a way that direction of normal to the real space parallel planes and separation of the point from origin is equal to the reciprocal of real interplanar distance. Real interplanar distance means in a direct lattice. So first we draw a direct lattice, or you can say crystal lattice. So in a crystal lattice, first I will take any unit cell in a crystal lattice. So this is a unit cell in a crystal lattice. I take this as a unit cell, cubic cell. So many lattice points are here because this is a one part, a building block of a crystal lattice. So I take this. There are so many lattice points. Each lattice points have atoms or molecules. So for example, here. Clear? So I take this unit cell. Now take the parallel planes of this. There are so many parallel planes, for example, which are I have seen here. This is a parallel plane. This is parallel to this plane. Clear? So take any arbitrary origin, at any point. Okay? Now draw perpendicular to these parallel planes. So one plane, another same type of unit cell is here, upward, downward. So many parallel planes. So draw a normal to these parallel planes. I draw a normal to these parallel planes. And what will be the length of this normal plane? The plane or normal to these planes, parallel planes. So the length assigned to this normal is 1 over d. 1 over d means where d is the distance between these two planes. For example, the distance between these two planes is this. So the length assigned to this normal is the distance between planes. So take a point at the end of this normal where the distance is 1 over d. So length assigned to this is 1 over d HKL. Here HKL is a set of planes. Similarly, so take a point here. Similarly, these are two parallel planes, 1 and 2, so many upward, downward. Clear? So this is another set of parallel planes. So same, from this origin draw a length parallel to this planes, normal to this plane. These two planes, draw a normal to these two planes. Same from here, draw a normal to these planes because there are so many planes downward. So the length assigned to this is same, that is 1 over d HKL. So take a point at the end of this normal where length is 1 over d HKL. Clear? Clear? See HKL, the values of HKL, H dash, K dash, L dash, dash. Similarly, another parallel planes, draw normal to another parallel planes and take point at the end where the distance is 1 over DHKL. Clear? So when we join these all points, when we join these, I am repeating again, draw normal to each set of parallel planes and take a point at the end where the length becomes 1 over DHKL, where D is the distance between the planes. Now these all points, when we join all these points, that joining become an array of points, and each point is a reciprocal lattice point, and these array of points, when we join these array of points, these becomes a reciprocal lattice. These becomes a array of points becomes a reciprocal lattice. So in this way, reciprocal lattice can be constructed from a direct lattice. So in this way, reciprocal lattice can be constructed from a direct lattice. Clear? So that I write here. So this is it is a set of imaginary points. These are the imaginary points. Set of imaginary points constructed in such a way that direction of normal draw किया to the real space parallel planes. Real space means direct lattice they जो parallel planes are उन्ना पे जो normal draw किया the direction of normal planes, and separation of the point from origin is equal to the reciprocal of real interplanar distance. Clear? So this is the definition of you can say reciprocal lattice. Now construction that I draw here. Construction, pick up a point as an origin in the direct lattice. So direct lattice कोई भी point ले ले which is the origin. Then draw normal to every set of planes from origin point in the direct lattice. So we draw normal from the origin to set of parallel planes. So for a particular set of planes, set the length of each normal equal to reciprocal of D. So length assigned to each normal is 1 over D. Here reciprocal of D, where D is interplanar distance, and put a point at the end of each normal. So put a point at the each end of the normal. So the collection of points so obtained gives a new array called the reciprocal lattice. So this is our reciprocal lattice. Clear how we can construct a reciprocal lattice. Now the properties of reciprocal lattice. What are the properties of reciprocal lattice? This is very important. Properties. The first is when we construct a reciprocal lattice, then we have the translational A, B, C. They are the translational primitive translational vectors of direct lattice. We have studied in the previous chapter. Now we want array of points gives a reciprocal lattice, so we want the primitive translational vectors of reciprocal lattice. So if A, B, C, this is first point. These are the properties, you can say properties of reciprocal lattice. If A, B, C are the primitive translational vectors of direct lattice, then the primitive, this is very important, primitive translational vectors of reciprocal lattice are, you can take any symbol. So I take A, B, C, या A star, B star, C star ले लो. A star, B star and C star. Yeah. So if A, B, C we take here, lattice parameter, primitive translation vector. For reciprocal lattice we take this. Then the length. If the length of A, B, C is having dimensions of centimeter, or you can say length, the dimensions of this are length, then the dimensions of this are inverse of that. For example, if the dimensions we say the dimensions of A, B, C are length. Length means centimeter or meter. Clear? Then dimensions of A star, B star, C star, that are length minus 1. Inverse length minus 1. Centimeter minus 1 or meter minus 1. Clear? Third, volume. Volume of reciprocal lattice. Volume of reciprocal lattice. Reciprocal lattice is inverse of volume of direct lattice. Volume of direct lattice. So direct lattice. Clear? ठीक है? These are the main properties. Fourth property, now reciprocal lattice vector. Reciprocal lattice vector. For example, we have translational vector, that is n1a, n2b, n3c. Same here we have a reciprocal lattice vector also. The reciprocal lattice vector, I write here the reciprocal lattice vector. Fourth point, reciprocal lattice vector, that is represented by G and G. Any, you can take any symbol. I take G. G is equal to H A star plus K B star plus L C star, where H, K, L are integers. So we in direct lattice we take T is equal to N1A, N2B, N3C. So same in this we take this. Yeah. Fourth, Bragg's law. Bragg's law we will do in the next lectures. Bragg's law in reciprocal lattice in an easy way. Clear? So these all are the properties of the reciprocal lattice. So diffraction methods are the map of reciprocal lattice also. So these are the properties. So ABC here in direct lattice, in reciprocal lattice, A star, B star, C star. Then dimensions inverse of the dimensions of direct lattice. Volume is also inversely proportional, and G reciprocal lattice is this. And the length assigned to reciprocal lattice vector is 1 over D. Length, this reciprocal lattice is normal to the crystal planes in the direct lattice. G is normal to the lattice planes in the direct lattice. So the length assigned to this is the inverse of the, or you can say G vector is, the magnitude of this is 1 over D. That's clear. Yeah. So next is the, now what are the values of A star, B star? Because we want A star, B star, C star here. So A star, B star, C star. How we can find out A star, B star, C star? So that is A star dot A. This is also a property. A star dot A, that is equal to B star dot B, that is equal to C star dot C. This is for reciprocal lattice. This is for direct lattice. This is equal to 2 pi. This is equal to 2 pi with the same combination, and with different combination, A star dot B is equal to A star dot C is equal to B star A is equal to B star C is equal to C star A is equal to C star B. Different combination, that is equal to 0. That is equal to 0. Clear? And another thing, A star is A star, similarly B star, similarly C star. So I will find the value of A star. Similarly, we can write the values of B star and C star. A star, that is a primitive translational vector of reciprocal lattice, is perpendicular to plane containing B and C. Plane defined या containing defined B and C. Simple B and C of direct lattice. Clear? If A star is perpendicular to the plane defined by B and C, then can I write A star is equal to any constant A B cross C. I write here, and A star dot A is that is equal to pi. So I write A star dot A that is equal to 2 pi. That is equal to 2 pi. So A star, similarly B star is perpendicular to plane defined by A and C. Similarly C star is perpendicular to a plane defined by A and B. So you can write similarly other combination. So A star dot A is equal to 2 pi, put the value of A star here. So when we put the value of A star, what do we get? A star that is equal to A, B cross C that is dot A that is equal to 2 pi. So from this you can find out the value of A. So A is equal to 2 pi upon, you can write it as A is B cross C, no problem. Clear? So put the value of A here in equation number, you can take equation number 1. So put the value of A here, what you get? A star is equal to 2 pi upon A vector dot B vector cross C into B cross C. So this is the value of A star. So this is the value of A star. This is the volume in a direct lattice. Clear? Clear? So this is A star. Similarly, you can write B star and C star. So B star is equal to, that we have to use in the next articles, these A star, B star, C star, the values of A star, B star, C star. So B star is equal to 2 pi upon same A dot B cross C. Okay? You can change, instead of A star you can write B here, C cross A, that will be same, result will be same. 2 pi B cross C, instead of B you can write C, and instead of C write A, change. C star is equal to 2 pi, change it, instead of C you can write A, instead of B you can write B, A star dot B cross C. So this is B and this is C and this is A. These are the primitive translational vectors of reciprocal lattice. So this is all about the reciprocal lattice, and in the next lectures we will study how the reciprocal lattice of a simple cubic is a simple cubic itself with some constants, and similarly the reciprocal lattice of VCC is reciprocal to FCC and vice versa. So that we will discuss in the next lectures. So thank you very much. This is a very important topic. So go through it. Thank you.